tell me
07.
Okay, fine. Then it's fine. Okay, so now the next point comes as far as this part is concerned. Where to stop? Where to stop the iteration for this U1? You are getting all the values of U1 closer and closer to the exact value of U1. Where to stop? This is already taught to you in your Maths 1, Maths 2. Where to stop? What should be the criteria?
Sir, when u1 of n plus 1 is equal to u1 of n, and that is previous iteration
Meaning by that two consecutive values are close
same.
enough.
Yeah.
But how much close enough? The next question comes. So that will depend on your tolerance, whether you want the answer correct to 3 decimal place, 2 decimal place, 4 decimal place, 5 decimal place, means your tolerance is 10 to the power 2, -2, -3, -4, and so on and so forth. Depending on that, the number of iterations will be less or more. Is that right? Is that right?
Yes, sir.
Okay, good. So these are the very simple points, but very crucial points that you have to understand. Now, suppose we have fixed our value of U1 at U13 and U13 value, I think it is there in the slide. Right. So U13, the value is coming to be 0.930703331. Suppose we fix our U1 at this stage, because you see 0.9307 up to 4 decimal place, or even up to 5 decimal place, or even up to 7 decimal place, it is the correct one. But 7 decimal place, if you continue, will be a difficult job. So it is better to stay with 3 to 4 decimal place at this stage. Now, next thing you have to, so if you fix your value at U13, the value of U1, so U1 is now U13, that the value turns out it is your 0.930703331, right? Now you have to proceed for U2, so you have to calculate U21. U21 is your U20 minus F is evaluated at U20 divided by F prime is evaluated at U20, right? Is that right? So what is U20? What will be your U20? Because you again require the initial guess for U2.
U12.
No, U13, up to U13 I have written, right? The last value I have written as U13. So whatever you have got for whatever you have fixed for U1, so put that U1 here. Put that U1 here. For example, 0.930703331. So this will be the value for your initial guess for your U2, 0.930703331. This value, that is your U1 value, will be the initial guess for that. Now you have to proceed for U2. You have to get your U21. U21 will be calculated, and then you have to go for U22. After that, there is no trouble. And then you have to go for U23 if you are going for your 3 decimal place, 2 decimal place. Accordingly, you have to go. So I have just U23 is 0.822, U22 is also 0.8224, and U23 is also 0.8224. So we can stop at this stage. You require up to only U2 because you have to solve over 0 to 0.4. If you have to solve for larger interval, accordingly the other values has to be calculated. Is this clear to everybody? Is this clear to everybody?
Yes, sir.
But this is not the only way to get the initial guess. There are several ways to get the initial guess. Whichever is closer, one picks up that for their own problem, right? So that's the point. So these are 2-3 things which has to be clear to you people. So is this clear now? Shall I move further to next part? Yes.
Yes, sir.
Okay. Now I will come back to your Taylor's method, which I have already taught you on the last turn. I told you people to see the chain rule. I hope you must have gone through the chain rule, right? So I will just close this slide and then I will load another slide. Hello? Are you people here?
Yes, sir.
Me? Something happened. Something happened and okay. Let me share the slide. Are you able to see the slide?
Yes, sir.
Yes, sir.
Okay, fine. At least I can continue. Okay, so I have opened that chain rule one. So u prime is given as f of tu, right? Hello? Are you able to hear?
Yes, sir.
Okay. And then what will be your u double prime? That is your, up to this I think I have told on the last one. It will be your d by dt of f tu, that is your ft plus del f by del u, and then du by dt, that is your u prime. So it is ft, fu into u prime is f, so it is f. Now if we want u triple prime, then it will be d by dt of u double prime, and that is your d by dt of this quantity. So this is your, this will be your ft plus fu into f. So first we'll see only ft part. So ft part, if we again differentiate with respect to t, so this will be ftt plus ftu u prime, and then we see the second part. This is a fu into the product of two functions. So we keep one still, and then other will differentiate. So this is fut plus fuu u prime, and then into f, and then we'll keep this fixed, that is your fu, and then the d by dt of f will be your ft plus fu u prime, and u prime can be replaced by f. And so finally we'll see that u triple prime is ftt plus 2 ftu I have written into f. 2 ftu into f, because one ftu is here, one other ftuf is here, and then fu in this, inside the bracket you can see that ft plus your f into fu plus the last one will be your fuu f square, fuu f square, this term. So all the terms are written for u triple prime. This is required for your Taylor's method. Now suppose we want the we want to apply the Taylor's method of second order on the same problem which you have done just for your using your backward Euler method. So your Taylor's method is your Taylor's method of order p. Now you want a Taylor's method of order 2. This is of order p, means the local truncation error will go up to capital order s to power p plus 1. So you if you want the order second order Taylor's method, second order Taylor's method. So what are the terms it will have? U j plus 1 equal to uj plus h uj prime plus second order. Second order means what? The local truncation error will be, for second order method, the local truncation error will be, this is your pth order method. If the slide is seen on your screen. Hello. Okay. So this is your pth order method. Means the local truncation error is of order capital order s to power p plus 1. So what will be the second order method? Local truncation error will be, capital order h cube term. So up to h square, that will go to the method, means h square u 2 factorial u double prime j. This will be your Taylor's method of order 2 or second order Taylor's method. Is this clear? Is this clear?
Yes, sir.
Okay. So you require u prime, that is given. U prime is given as f. U double prime will be what? Either you write the f directly. F is what? Minus 2x for that problem. 2x u square. So what will be u double prime? What will be u double prime in this case? Quickly tell me. What will be u double prime here? You differentiate this directly. Minus 2x u square. Tell me quickly.
Minus 2u square minus 4x u prime.
U dash. Is that clear? Either you use the function directly or you can using your formula. Remembering formula is a difficult job. So you just understand the chain rule, do it there itself so that you will get that. Right? Is this clear? So can you find out the u naught is given? Everything is given. So can you find out u1? u1 will be your u0 plus h u prime 0 plus h square by 2 factorial u double prime 0. So u double prime you have already written. Find out u prime 0 and u double prime 0. U prime 0 is nothing but your minus 2 x is 0, so that goes to 0. Whatever it may be, that u0 does not matter at all. Then find out u double prime 0. Find out u double prime 0. Quickly, not much time is left. Anybody? Yes.
So what is u0?
Tell me what is u0. Tell me what is u0.
Sir, minus 2.
No, u0. Somebody asked me that what is u0. What is the problem? U prime equal to minus 2x u square with u0 equal to 1, the same problem. So what is u0? U naught is 1.
Then it will be minus 2. Yes, sir.
Pardon me?
It will be minus 2, u double prime 0.
U double prime 0. What will be the answer? You can verify with 1 upon 1 plus x square at the point x equal to 1. So what is u1 from the exact one? It is 1 upon 1 plus. Yes, tell me quickly. X1 is what? 0.2 square. So it is 1 upon 1.04. Whatever the value is that, it should come like this, close to that. Is this coming close to that? Somebody was telling the answer also. Somebody was telling the answer also. Girish? Girish?
Yes, sir.
Tell me. Did you get the
Uh,
value of U1?
By
Using
Taylor's method.
by Taylor's method, obviously.
Sir, I'm solving it.
Okay. Anybody else got? Bhavna?
Sir, just a
Bhavna?
minute.
Okay, okay. Chinmay Jain?
Sir, I am solving it.
Okay, okay. Do it quickly. Is this clear or not? The point is that everything I have told. You can compare with the exact solution that I have already told, that is 1 upon 1 plus x square. U1 will be 1 upon 1.04. So whatever the value comes out to be should be the same, closer to that one.
Zero 0.96.
0.96. No, you should use some more digits, otherwise there will be trouble.
It is like 1 minus 0.04.
No, you are telling exact value, or you are telling that Taylor's method
Sir, we
second
are
order?
getting 0.96.
0.96. Sir,
Sir, 0.96.
Right. Others? What is the exact value? You have the calculator. What is the exact value? Cyan?
Sir, it's
So the
1 minus
exact value
0.04.
is 0.961538.
Okay, okay. So you just go for one or two more digit. So if you want to apply higher order Taylor's method, you require, for example, your fourth order, you require your U triple prime, fifth order, you require sixth. So accordingly, you have to calculate more and more chain rules. Is that right?
Yes, sir.
Another thing which I have raised question on the last turn, I may not be able to tell today again, that if our tolerance is given, now the word tolerance is clear to you people. If up to what it is given that up to what decimal place we want the correct answer, suppose it is given. So how many terms of the series you have to take so that you can get that tolerance? Prior to that, can you think of? Can anybody give me the idea?
Like it should be more than the tolerance.
Tell
It should
me
be
again. Tell me again. I couldn't see here.
It should be more than the tolerance, because we need to find up exact
What
value of
should be the more
tolerance.
than the tolerance? What should be the more than the tolerance?
It may depend on us that how far we should go, but it should be more than tolerance.
No. My point is, before a tolerance is given, suppose tolerance is given to you, and you are asked to find out how many terms of that Taylor series you require to get this tolerance. So how will you find that? Chinmay Jain, Bhavna, Sneh Bandhu,
Yes,
anybody? You see what is the local truncation error? It is known to you.
yes,
Local trunk.
order of
So
h cube.
if the maximum magnitude of the local truncation error is less than the tolerance, your job is done. That is the part which is telling about the error. So okay, think about that. So I have already given a bit of hint, and the next turn, that is on Saturday, 4 to 6, we'll discuss this, that how we can do that. Is it possible or not? And then we'll move further for the another part, that is your some definitions which I told earlier that I will tell you. So on that day I will tell the definition, and then I will move to the Rangekutta, the basic idea, how the Rangekutta got the idea to do to find out those methods, and so on and so forth, and then we'll derive the Rangekutta method, right? Meanwhile, you all of you should revise that interpolation which is told to you, in your Maths 1 and Maths 2. Okay, then for today, I will just close at this stage. Any query, if it is there, you can ask on the next round. Okay.
Thank you, sir.
Thank you, sir.
Thank you, sir.